Here we define the factorial of n by the products of all positive integers not greater than n, and denote by this notation, n followed by an exclamation mark. So we have the factorial of 1 equals to 1, the factorial of 2 equals to 2 times 1, that is 2, and the factorial of 3 is 3 times 2 times 1, that is 6. The factorial of 4 is 4 times 3 times 2 times 1, that is 4 times 6, 24. The factorial of 5 is 5 times 4 times 3 times 2 times 1, or 5 times 4 factorial, that is 5 times 24, or 120. Factorial of 6 is 6 times the factorial of 5, that is 6 times 120, that is 720. We have a special case, that is the factorial of 0. It is defined as 1. Here is an example. 10 factorial divided by 7 factorial can be written as 10 factorial is 7 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So just write 7 factorial at the end, divided by 7 factorial. So it is equals to 10 times 9 times 8. That is 720. Similarly, the factorial of 15 divided by the factorial of 11 is equals to 15 times 14 times 13 times 12. This is another notation, NCR. This is the factorial of n divided by the products of the factorial r and the factorial of n minus r. For example, 6c4 is 6 factorial divided by 4 factorial, and 6 minus 4 is 2, so this is 2 factorial. And this is equal to 6 times 5 times the factorial of 4 over the factorial of 4 times 2 times 1. So this is 6 times 5 over 2 times 1. This is 15. (40c0) is the factorial of 40 over the factorial of 40 times the factorial of 0. And the factorial of 0 is defined as 1, so this is equals to 1. 100c98 is 100 factorial over 98 factorial over 100 minus 98 is 2, so this is 2 factorial. This is equals to 100 times 99 times 98 factorial. And the factorial of 2 is just 2. So we can cancel out 98 factorial. So this one is equals to 100 times 99 over 2. So it is 4,950. You can use a calculator to find factorials and NCR. You see that this is the button x factorial, and this is the button shift. You have to press the number first and then press shift and x factorial. Here is the button NCR. To find, for example, 6c4, you have to press 6 first and then press shift and this button and press 4, and of course press the button EXE. We have some properties of NCR. First, NC0. It is the factorial of n divided by the factorial of 0 and the factorial of n. Because the factorial of 0 is 1, so NC0 is equals to 1. NC1 is the factorial of n divided by the factorial of 1 and the factorial of n minus 1. The factorial of 1 is 1 and the factorial of n is n times the factorial of n minus 1. So this is equals to n. Here, the factorial of n minus 1 is the product of all integers not greater than n minus 1. And if you multiply n, then it will become the product of all integers not less than n, and it is the factorial of n. NC2 is similar. We write n factorial as n times n minus 1 times the factorial of n minus 2 divided by factorial of 2 and the factorial of n minus 2. And we cancel out these 2, so we have n times n minus 1 over the factorial of 2. In general, NCK is equals to n times n minus 1 times n minus 2 up to n minus k plus 1 over the factorial of k. Here in the numerators are the largest k integers not greater than n. This is the proof of this identity. Okay, by definition, we have NCN minus r is that. Note that n minus r is equals to r. So this one is actually equals to NCR. This is the proof of the second identity. This is just the definitions of NCR minus 1 and NCR, and n minus the brackets r minus 1 is equal to n minus r plus 1. Take a look at the denominators. Here we have the factorial of r minus 1, and here we have the factorial of r. Note that r times r minus 1 factorial is equals to r factorial because r is larger than r minus 1 by 1. This is just like 8 times 7 factorial is equals to 8 factorial. So here we multiply both the denominator and numerator by r. And we also have n minus r plus 1 is 1 larger than n minus r. So we have n minus r plus 1 times n minus r factorial is equals to n minus r plus 1 factorial. So here we multiply both the denominator and numerator by n minus r plus 1. So the denominator of the first term is just equals to r factorial times n minus r plus 1 factorial. And the denominator of the second terms is also equals to r factorial times n minus r plus 1 factorials. So they have the same denominator. And for the numerator, it is n factorial times this r and plus this n minus r plus 1. But this sum is equals to n plus 1. n plus 1 times n factorial is n plus 1 factorial. And we arrange the terms in this brackets. This is equals to n plus 1 minus r. So this is the definitions of n plus 1 CR. So we have proved this identity. Okay, for example, 10C8 by the first identity, it is equals to 10C2. And we know that 10C2 is the product of the largest two integers not greater than 10 over 2 factorial, that is 2. So this is equals to 45. And 70C2 minus 69C2. Using the second identity, we have 70C2 is equals to 69C1 plus 69C2. Just take n equal to 69 and r equals to 2. So this one is equal to 69C1. That is 69. For this one, 50C48 is equals to 50C2. And the sum of these two is equals to 51C3. So it is 51 times 50 times 49 over the factorial of 3, that is 6. You may try these challenging questions. Here is a hint. Note that NCN is equals to NC0, and so it is equals to 1. So we have 2C2 is equals to 3C3 because both of them are equal to 1.